in the word exponential?
Exponent.
Yeah, an exponent. Well, we just talked about exponents a lot, like a lot, in section 6.1 and 6.2. Now, I mentioned a second ago that this form can get really confusing because this form has A's and B's instead of numbers. So can I go ahead and, actually, let's come over here and see what you guys circled, and we'll see if you got it right. Which of these, I'll give you a hint, there are two of them. Which of these are exponential functions? You have the first option, you have the second option, the third, or the fourth. Give me one that you guys circled. Yeah, go ahead, Jerry.
1.
Do you guys agree?
Yeah.
Give me a thumbs up if you say yep. I agree too. So, even though over here you guys wrote down a times b to the x is how we could say that, or a times b to the x exponent, you realize you're allowed to have numbers in those a and b spots. A and b are just kind of like placeholders. So that was one exponential function. There's one more. Can you guys just vote for the other one when I read off the number? How many of you guys think that number 2 is the other exponential? Number 2? How many of you guys think number 3 is the other exponential? How do you guys think number 4 is the other exponential?
I think number 4.
It's not this one. Because this one is of the form y equals mx plus b. And you might not remember, but that's a line. Now this one's weird. You could have had like a plus 0, but this is definitely a line. It's not an exponential function. That's like last year equation. But we're stuck between this 2x cubed and this negative 3 to the x. So can I come over here and make a quick note, and then we'll vote again and see what you guys think. When you wrote down, or when you guys all chose 4 times 7 to the x power, I came over here and said, okay, you know that a and b are constants. I think we better write that down. A and b are both constants. Now technically, maybe I should be a little careful though, because even though a and b are constants, and that's very, very true, I'm going to zoom in and label them because even though they're constants, they have different meanings, different jobs, different purposes, okay? So let's come back to this first page. Let me zoom in on that a times b to the x, because I can tell that we didn't totally get, which is fine, this is a formula. It's kind of like an abstract way of talking about it. Exactly what these guys are. So I'm going to go ahead and label A. I want you guys to put a little dot after A, like a multiplication dot. Okay? I want you to put a little dot after A, a little multiplication dot. Because A is actually our coefficient. Now you guys have seen this word before. I know you have. A coefficient. If I was to give you something like 2x, right? Just 2x, just an expression, an algebraic expression. Who's the coefficient? 2, and who's the variable? Yeah, 2 is the coefficient, and x is the variable. So a, in this one, a is the coefficient. It's like the number that's multiplied in front. Now b, he's also a number. B is also a number, but b, even though he's a constant, even though he's a number, he is the base. Wait a minute, base. We talked about bases. There were bases in the rational exponent form in section 6.2, and there were bases like in the radical, and there were bases with exponents. We have a coefficient, we have a base that are both numbers. We have a coefficient and a base, and that base goes with our, you guys have already explained to me, exponents are an important thing. The base has the exponent. And x is a variable. Okay, so a and b, numbers, x is a variable. The exponent is a variable. I think out of everything on this page, when we're talking about exponential functions, one of the most important things to remember is that there is a variable in the exponent. That's what's new. That's what's different. Because normally we have variables down here with constant exponents. But this isn't called an exponential function because there's a constant in the exponent. An exponential function is one such that there's a variable in the exponent. Now there's some words down here to try to explain some of that. I tried to do the short and sweet version with colors because I like that better. But this one says, okay, a can't be 0. If a was 0, everything disappears, so there goes your exponential function. B can't be 1. This is a weird one that might be kind of hard to explain, but basically 1 to any exponent is just 1. He's a super boring one. He's never going to change. And we're only looking for positives. There are some little rules that have to be true. And there's a little pattern that's going to be true in a table. But can we go back right now to the examples? And you guys were trying to find for me the exponential functions. Why is number 2 wrong, even though the majority of the class voted for it? Why is number 2 wrong? Raise your hand, raise your hand. Levi. You had it, you had it. You started to say it. Why is number 2 wrong? It's okay, I won't pressure you. Jerry's gonna steal it from you. Go ahead.
Because there's a 1, like, and right next to the 2 is like, there's always a 1. Right
yeah,
there.
it's 2 to the 1, that's true.
And it doesn't really follow.
Why doesn't it follow the pattern? I agree. It doesn't follow what needs to be true. What needs to be true in the exponent. If you guys need to, just box the exponent. What needs to be true in the exponent? A variable. What's there? A number. So check out this one. What's true with his exponent? Oh, I just totally wrote over it. What's true with this exponent, guys? Yeah. Number 4 is my other one, not number 2. Number 2 has a constant in the exponent. That doesn't work. Number 4 has a variable. Now some of you are like, but it doesn't work. Can I show you how else we could write this? We could write it as 3, who's the base, to the x. Well, let me do it with colors. That negative could be a negative 1. Times. I can write it like that, Paige. Because negative 1 times anything makes a negative. 3 could be my base, and x could be my exponent. I could write it such that it fits that pattern. This one, there's absolutely no way, because the x is down and the constant is up. So every exponential function has what in the exponent, guys? A variable. It has to have a variable. You guys saw it here. You picked it out real good. You just got confused here because you saw the 2 spaces and you didn't realize, no, those both have to be numbers. And what's most important is the variable up. Okay, good? Yeah. Now, there's one little baby piece that we didn't fill in before we leave our notes and go work on homework questions the rest of the time. Do you see where it says in tables? Now, some of you guys might have left space here and some of you might not. That's okay. I'm just going to show you real quick a baby table. Most of you can probably fit this in. We're going to do a sideways table. Sometimes we do up and down tables. Sometimes we do sideways tables. When we do tables, we normally do x's and y's. You guys should have seen tables last year when you were doing linear graphs. At least sometimes. Maybe you chose like x equals negative 2, negative 1, 0, 1, 2 to plug in. That's something that you would have done with lines. But in tables, I just want to show you what all of these words mean, because all of these words, that's not mine, turn it up. All of these words are trying to point us to a pattern, okay? So if you want, this is all talking about the pattern in tables to look out for. The pattern in tables to look out for. So this says, as the x terms, as the top row, add a constant, the y terms multiply a constant. As the x terms add a constant, the y terms multiply a constant. So I'm just going to give you an easy example, even easier than the ones over here. The ones over here, 4 times 7 to the x, that's going to get really big really fast. And negative 3 to the x has a negative. Why don't we just do, as an example, y equals, let's do 3 to the x. Not the negative from the page over there, but just a positive. Just a positive 3 to the x. Okay. Now, I'm going to make it a little bit easier. Maybe we'll get a little bit harder. Instead of doing -2, -1, 0, 1, 2, can I just do 0, 1, 2, 3? I'm not going to do negative numbers because in exponents, we should probably wait until tomorrow to do that. As the x's add, you see how the x's are just going up by 1 every time? So the pattern says, as the x's add a constant, what are the y's supposed to do? Multiply. Now this is something where we kind of have to plug it in down here if you wanted to see what's really going on. But when x is 0, we plug it in, 3 to the 0. Or when x is 1, we plug it in, 3 to the 1. When x is 2. When x is 3. When we're adding 1 to the exponent is going to go up every time. But I'm curious what happens when we simplify. Guys, what's any base to the 0 power? Do you remember? Good. Yeah, it's either 0 or 1. You have to get that straight. It's in our little book. Anything to the 0 power is 1. But what's 3 to the 1 power? 3. What's 3 squared? 3 times 3. What's 3 cubed?
27.
Okay. We're only adding 1 to x's, but do you see what's happening to the y's? What's it being multiplied by every time?
3.
That's the pattern that you'll always see for exponential functions in tables. Now in graphs, it's going to look a little bit different. It's going to actually end up being like a swoop. There it is, and we're going to see it tomorrow when we get to graphs. But for today, all we need to worry about is who is an exponential function. It's a function that has a coefficient, a base, and an exponent. And what's key, what's most important, is what is in the exponent? Variable. And then in the table, x's are going to add and y's are going to multiply. For right now, though, guys, that's enough. That's enough. So let's go ahead and close up our notes. Let's go to section 6.2, because that's what the quiz is on tomorrow. We have introduced section 6.3. Perfect. No homework on 6.3 tonight. No writing homework. Instead, what I am advising you to do is what I advised you to do last time. Study, but don't just stare at it. Woo! Try a problem. Try a blank problem. Try a blank problem without a solution. Now, I do want you guys to go ahead and see last week's quiz. Just remember, it was only a few problems. That is straight out of the homework if you want to check me. When you hear your name, just start walking towards me quick. I'm going to give you last week's quiz starting in my mind. Isaiah, Adrian, Andrew Bosch, Sonny, Barry. Come towards me. And first you're both. All of you. Sherry, Melanie, Jonathan, Elizabeth, Everett, Hannah, Caleb, Radical, that's the section that we're doing for a quiz tomorrow. Armando, Caleb, Andre, Andrew Casper, Trey, Alexis, Diana, Daniel, Sean, Jason, Jared. You guys did not take your quiz. It might have been that you were absent and you come in during the lunchtime. Four cubed, you could have left as 4 cubed. But the direction was to simplify the exponent. Now guys, I want you to hold on to this because the test is coming and we're going to go over these quizzes to go over your mistakes before the test. But do you realize that I gave partial credit? Every question was worth 2. And some of you I took off maybe a -1 if there was kind of a bigger mistake. Or if it was a tiny mistake, maybe I took off -0.5, depending on what kind of mistake it was. Or if it was really big but you got something kind of right, maybe I took off -1.5. It kind of depended. But if you want to come talk to me about your quiz, I know a few of you might want to. Come on in, I can show you mistakes. But the long story short is the majority of you got at least half of it right, if not more, which is good, but we want to keep on raising that percentage. Now, hold on. All of these questions came from where again? Homework. The homework. And it wasn't a long quiz. It was like, you're always going to have 3 to 5 questions. So what's the quiz tomorrow? These problems. It's out of these problems. So let's go ahead and go over questions on homework for tomorrow. Now, we'll go over these before the test so we can review section 6.1. Put it in your binder, in your folder. Store it away safely. I had 3 of you guys that didn't get it back, and that's totally okay. You're going to make it up with me or make it up with someone upstairs. But for the rest of you guys, we have, actually for all of you guys, we have a quiz tomorrow on section 6.2. So we're reviewing real fast section 6.2. And I'm going to go ahead in your notes and go to the very beginning of section 6.2 where we were first talking about radical and exponential expressions. This is probably the most important page that I might refer back to multiple times. So on your desks, if I were you, I would have a highlighter and a colored pen, because you might want to make some special notes in making sure you have everything good to go right now. So we have 13 through 28 and 31 and 33 that we didn't grade yet. Now guys, I'm going to put all of them, evens and odds. Maybe for grading we should just do evens. They're not going to fit otherwise. There we go. And let me zoom out just a little bit so you guys can see them. So I want you to know whether or not you were right or wrong. Here we go. This is page 303. All the evens. Because the odds are in the back of the book. You have already graded those. So I want you to see right now if you got the evens right, first of all. And then I'm going to start going over whatever questions you have on the puzzle time or numbers 13 through 28. Or numbers 13 through 28, 31, and 33. Now remember, if it's a crazy hard problem, it's probably not on the quiz tomorrow. But it's a good idea for you guys to ask me if you're not sure. Let me get here. My expo mark. So we have a question already on number 18. With not a real number, yeah, that probably won't be on the quiz tomorrow. An answer of not a real number, I probably won't have on the quiz tomorrow. I can tell you, I won't have number 18 on the quiz. But there are other ones that you might want to go over questions. Andrew Bosch, focus. Thank you. Can I scroll down a little bit because some of the ones at the bottom are hard to see? 28's right here, 2,401.
If you putting the 2 in there, would it still be correct? For 22?
Yes, but maybe I'll look at that one. That's a good question to go over. I have a question on number 22. Do you guys have any other questions that you want me to look at? I'm starting to write down questions I'm going to go over. Jerry? I have 22. I have 31. Andrew? 16 and 28. Anything else anybody wants me to add right now? Adrian? 19 and 20. All right, guys. I have quite a few, so... Oh, good. 28. Yeah, we have that one.
21.
21.
26.
21's okay. 22, 24, 26. Okay. I have enough questions to get us started. Okay, so let's go ahead and start off at number 16. That's where we're going to start. And if we have time for some more, we will. Remember, I'm here during lunch and after school, but I'm leaving at 4:30-ish, 4:45-ish to head to Chick-fil-A because I'm a part of that fundraiser tonight, which I'd love to see you. Hey, if you want to study math, come to Chick-fil-A. I'll be there. Anyway, so who wants to study math at Chick-fil-A, though? Oh, you do. All right, number 16 starts off with the negative fifth root of a big number, yeah? And number 16 has 1,024. Now, guys, tomorrow on the quiz, I might not have one of the huge numbers because it's not going to take a lot of time. Yeah. Right? It's going to take a lot of time for you to solve. And I don't necessarily want, like, some people to have calculators and some people to not have calculators, and then it becomes like a not fair sort of thing. So I'm going to probably give you smaller numbers, unless we want to commit right now for everyone to bring a calculator to the quiz tomorrow. How many of you guys are like, I'd rather use a calculator, so can we just have the whole class agree that if they bring it, they can use it, and if they don't, they can't? How many of you guys want to use a calculator on the quiz tomorrow? Well, yeah, that's kind of a dilemma. I might have the bigger numbers. I'm only got one version of the quiz, though. I haven't made it yet, so I'm choosing right now. Do we want the bigger numbers with the calculator, or do we want the smaller numbers without a calculator? It's a hard call. Okay, we're gonna vote. We're gonna vote. How many of you guys would say bigger numbers with the calculator? Okay, how many of you guys would say smaller numbers without a calculator? Okay. I'm gonna do smaller numbers without a calculator. However, if you're taking the quiz tomorrow and you get stuck on a fact, I will be walking around with one of the little baby calculators, and if you need me to do a quick multiplication division, I will, okay? So I'll do the smaller numbers without a calculator so everybody's on the same page, but I will be walking around with a calculator. I will do a quick little fact for you if you need it. Does that make sense?
Yeah.
Cool. So with this one, 1024, I'm not going to go through the huge process of breaking it down. Can you guys just tell me how many 2's were in that? Did anybody figure out how many 2's are in 1024? Oh, you guys didn't figure out how many 2's?
No.
Okay, I can do it quick then. 512, 256, 128, 64, 32. Ugh, are there way more than 5 2's in here? 16, 8. Okay. I see way more 2's. So maybe instead of going by 2's, maybe I'm going to go by 4's instead, which is every 2 2's. Guess how many 4's there were? 1, 2, 3, 4. Ha. Do you need me to turn off the front light?
Yeah.
So I tried to break it down into 2's. The problem was there were like 8 2's, or 10 2's. Way more than the ones that I was trying to do. So instead of going by 2's, I went by 4's. And I noticed, hey, there are 5 4's multiplied together to make 1024. So guys, what can I do if I see a fifth root of something to the 5th power? I can cancel it out and I get a 4, but what do I need to not forget? The negative. Does that make sense? Number 16? My next question is number 19. Number 19 gives me the 5th root of 8. Let me put number 26 over here. The 5th root of 8, all raised to the 4th power? Okay. All raised to the 4th power. Now, did you guys write that down too? It's the 5th root, right? Yeah. This one actually doesn't say solve, which is really nice, because this one we were actually supposed to simplify all the way. And in simplifying, we were trying to break down the big number into exponents of a base and then cancel. But if this one just says rewrite, do you guys get that we're just trying to take this and make a fraction out of it? What's supposed to be, remember this line is for the radical. Where does this 5 go? In the top or in the bottom? Good. And where does the 4 go? On top. So that is one way of rewriting it. Now some of you actually might have seen that 8 could also be rewritten as 2 cubed. So if you were being kind of crazy, smart, and rewriting 8, you actually could have gotten 2 cubed to the power of 4/5. And you would have had to actually simplify that to be 2 to the 12 over 5. I just wanted to show you that that's also right, but I would have been totally fine with just the basic rewriting of 8 to the 4/5. Sorry, that sideways, my bad. Some of you guys were kinking your neck. I would have been totally fine with 8 to the 4/5, but some of you might have done this one. If so, that was an awesome job. It just wasn't necessary. Now for number 20, you guys have another rewriting one. You have the 5th root of, is it negative 20? Negative 21, all raised to the 6th power. So what's the very first thing that you guys should do in rewriting this one? Yeah, I would do the negative 21. And then you need to make what in the exponent? a fraction, as the fraction. But yeah, the 6 and the 5. So who goes where? Who goes on top? 6. And who goes on bottom? 5. Good. You guys are doing a good job of rewriting the forms. The parentheses, actually, you would just keep it around that negative 21. That was my bad. Because that negative, we have to tie in. We have to keep it inside since it's inside to begin with. Yeah. Our next one was number 22. So I can tell that on some of the evens we got a little stuck, huh? On number 22, it gave us 9 to the, double check me guys, 9 to the 5 halves power. Is that right? Okay. Now, there are 2 ways to go, and there's no shame in either way. Both ways is good. Both ways are good. One way says, hold on, isn't 9 3 squared? Do you guys agree with that? One way says, I'm just going to keep it as it's written and go that 9 is 3 squared and replace it. And let me double check the directions. Oh, I'm just supposed to rewrite it. I'm sorry. I didn't look at the directions. The directions were just rewrite. We're not actually solving. So guys, you would write a radical. What kind of radical is it? Is it a 5th root or a square root? Square root, good, because the 2 goes here. You can write the 2, that's fine, but remember it's an understood 2. And what's going to go underneath? 9 to the 5th power. You could put the 5th there, that's okay. Or you could have also done the square root of 9 to the 5th power. Both of these are correct. Both of them are fine. I don't mind either one. Yeah, Kayla. No, you would get credit. I would probably just like write a little note, like it's understood, you don't need it, but that's okay. I know that you know what's going on. Okay, now we're moving on, I think, to some of the harder ones with number 24. So let me go ahead and erase this real fast. The directions on number 24 are evaluate. That means we're supposed to go all the way, okay? So we're supposed to evaluate, we're supposed to go all the way as far as solving. So let me write the directions of evaluate. And this is, guys, this is, to be honest, I'll probably have 2 rewriting problems tomorrow if you want to write that down. One from the rational exponent to radical, and one from the radical to the rational exponent. I'll probably have 2 rewriting, but then I'm going to have 2 evaluating, okay? So that's why we should pay attention to these ones. Number 24 gives us 125 to the 2/3 power. Okay. What goes into 125? Yeah. And some of you know, and maybe from homework, you figured out that it was 5 cubed. 5 times 5 times 5, right? Okay. So one way to go is you could have said, hey, 125 is 5 cubed raised to the 2/3 power. And if you remembered your power to power property without ever going to a radical, we'll go to a radical in just 1 second, and that was also a very good way to go. But if you didn't go to radical form, you could have actually done 5 to the 3/1 times 2/3. What does that become, guys? 3/1. My marker's a little bit dull, huh? 3/1. What happens to the 3 in the numerator and the 3 in the denominator? Or when you multiply and get 6/3, what does that become? 2. Yeah. So my 3's end up canceling the cubed and the cubed root, and you get 5 squared. Or you could have written 25. So this little third and the 3rd root actually end up canceling. But if you did this as a radical, you could have figured out the exact same thing. Because the 3 would have come out. I don't know who's making me laugh. Come on, guys, help me focus. The cubed root is outside, and then the squared is inside. Do you guys agree with where I put my 2 and where I put my 3? Yeah. Okay, and we just said that 125 is 5 cubed, right? So what can we do with the 3's? Yeah, the cubed root can cancel with the cubed power. And I can have 5 squared, which is 25. So could you have gone to radical form? Yes. Could you have just kept it in exponential form and gotten to the same place? Yes. That's an example of going 2 different ways. Now, guys, on the quiz tomorrow, I don't need you to go 2 different ways. I just need you to go a way that works for you. So if this one is nicer, go this direction. If you're like, I think I'd rather just not go to a radical, I can understand it. That's cool too. But the point is to show me some work so that if you remember the one you just got back, if you get the wrong final answer, if you make a little mistake, I at least know that you knew the direction you were headed. You did something right. Does that make sense? Okay. That was number 24. Let's go to number 28. That's the next one. Number 28, I think, is also an evaluating problem, but this one, it's a big number. 343 to the 4/3. Now, I know some of you guys already figured out how to break this down last night. So 343, how did you guys break that down? The light's just not nice on it, huh? But 343, you divided it by something, right?
Yeah.
What'd you divide it by? You don't remember? What was the base in your guys' answer? 3? Did 3 work? I don't think 3 went in. Yeah, I don't think 7 went in? Okay. Let's try 343. And if we do 343, I heard some different numbers. Does 7 go in? 7 goes in 4 times? 49 times. 7 goes in 49 times. That would have been one definitely to use your calculator on. Because 3, it looks like it does, but it wouldn't have gone in. It would have been a decimal. You would have tried, does 4 go in? Does 5 go in? Does 6 go in? Does 7 go in? Oh, finally. And what's nice about 7, guys? What's 49? So can't I replace 343? If I'm doing the exponential way, I could replace it with 7 cubed. And what's going to happen with the cubed and the third? What happened up here when we had the cubed and the third? Cancels out and you're left with the squared, right? So what's going to happen down here? It's going to reduce away. 7 to the 4th is the final answer. But if you guys like radical form, remember, you can do it that way also. You could have written under the radical, it's a cubed root to the 4th power, and it's 7 cubed. What happens still with the 3's? They cancel out. So whichever way you do it, the 3's are going to cancel. And remember, since you don't have a calculator tomorrow, I won't make you keep going. 7 to the 4th is a great answer. Is that okay? Yeah. All right. We have 2 more questions left, 26 and then 31. 26 is actually in the same section. So I think I'm going to pop down to number 31 just because it was in a different section. And it was right towards the end of homework. If you want to see number 26, pop on by my room during lunch or after school. But number 31, it looked a little weird because it was 1 over 1,000 to the 1/3 power. Now I'm just going to go to radical form because we're looking for groups of 3. But did you guys realize that 1,000 can be broken down into tens? And how many tens? Did anybody figure that out? Yeah, 10 to the power of 3, or 10 cubed. It's an understood one. 1/3. Does that make sense, Jerry? Yeah. So it's a 1/3, so the 1 is outside, the 3rd is inside. Do you guys see what's going to happen with the 3's? We can actually cancel out those 3's, and we're going to end up with 1 over 10. Now, this is kind of dangerous. It could get you in trouble in harder problems. But we could actually have made that 1 cubed also, which is why it was legal. For number 31, you want to break down 1,000. Okay, hold on. So, everybody, eyes up here. We have a quiz tomorrow, but it's just a homework quiz. Is it supposed to take a lot of class? No. Very little bit at the beginning. It's going to be printed off for you. 3 to 5 problems. Wait, I already told you what the problems are. 2 rewriting, from radical to rational exponential, and then the other direction. And 2 evaluating, so simplifying down. Are the numbers going to be huge? No. Like, well, as you walk around the calculator, you need that real quick. Homework tonight is just to study. But to study, my advice is to practice some of the homework problems over again. Bye, guys. I'll see you. Come in during lunch after school if you want to go over some practice problems or asking more questions. Good job, guys.